Good morning. This is Shinya Yoneki from JTEKT Japan. Today, I'd like to explain our approach to introduce Spark for EPS software development. I'd like to start from background of the current situation regarding automotive industry. So in these days, automotive industry start to introduce new functionality such as autonomous automated driving or by-wire systems. And for that system, we need the software for wide or great amount of software is needed. And software is becoming complex and also related to each other strongly. So it is very difficult to assure the quality and safety. So we decided to try to apply a formal method or formal verification in our software development. And I will speak about software quality at first. So as I mentioned, so currently automotive industry should have to deal with the change of amount of software. I mean that the software is becoming bigger and bigger, and complexity is also increasing with strong safety requirements. And currently, so new ISO 2626 standard, which was published in 2018, mentioned several methodology to deal with such software development. And there are several methodology. I listed such methodology in the table below. And we focus on formal verification. Why? Because so this method can ensure the software coding itself in parallel with specification, because so something issue found during the coding phase, it might be caused from software coding itself or lack of specification or wrong specification. And if we use software development by a formal verification, we can address these issues in parallel. That's why, in order to ensure the quality with limited time span, this method can help us strongly. And also, we have to consider the safety. So, in a conventional EPS system, of course, we also consider the safety, but in the previous systems, if something wrong behavior is found, then we can shut out the software behavior itself. For example, emergency stop or something like that. But currently, as I mentioned in earlier, current system is used by automated driving. Let's imagine if automated driving is suddenly stopped, then we could not deal with such situation. That's why our software should maintain its functionality. That is new kind of safety requirements, and it is not allowed to shut off the software behavior itself. So we are already facing with such situation maybe 2 or 3 years ago. That's why ISO 2626 already introduced some short guidance according to such new kind of safety requirements, namely fault avoidance or fault tolerance. But ISO 2626 does not provide any guideline to realize such requirements. So we are considering how we address such issues, and JTEKT decided to focus on formal verification again. here, so if we use formal verification, we can demonstrate in a mathematical way that our software can behave as intended. That is a strong point compared with conventional testing, for example, because so testing can identify some software error or specification error if the test case is addresses exactly such issues. But if the test case does not cover such issue, we could not find out such shortcomings or erroneous specification or wrong coding, etc. But if we apply a formal verification in this area, we can identify such issues with a logical way. So if we can demonstrate that our software does not have such errors or fault, then we can demonstrate that our software is fault-free by logical way of logical proof. That's why we decided to apply formal verification in our software development. Then, why we decided to use Spark? As you know, there are several other methods to use formal verification or formal method. For example, CBMC is a model checking-based formal verification method, which can be applied to C source code directly. And also, Flamashy is a theorem proving method. This is also applicable to C language. And but for the Spark, we need C source code to Spark. So that is one drawback. But comparing with two software tools, Spark has strong points. That is that the tool itself is already qualified in accordance with ISO 26262 Pathway 8. That is quite a strong point because if we decide to use this method, we should have to explain our customer that our verification method is strong enough with some reliability or confidence. But CBMC or Flamashy does not have such support at all because they're more, let's say, research and development types of tools, so not intended to apply mass production products. Comparing with these two software tools, Spark can be supported strongly for qualification of software tools. So if we decide to apply Spark to our software development, we can also provide our customer that the Spark tool itself have a strong level of confidence. That is a very important point for current automotive industry needs. That's why we decide Spark. Then next, I'd like to explain how Spark is used in our software development processes. At first, we have to convert C existing source code into Spark language. As I mentioned, so Spark is different from C language, of course. So we should change the C language into Spark. That is a mandatory process if we decide to Spark. So there are some kind of difficulty, but comparing with the benefit, we can accept this point. Anyway, so once we convert C to Spark, then we can go to the phase of verification. And Spark has two kinds of verification methods. One is to check if whether runtime error is existing in our software or not. That is one point. And the second point is that software is exactly implemented as we intended. And if we use Spark as first point, I mean, our software does not contain any runtime error, then we don't need any additional effort. Just ask Spark whether our software is perfect or not from runtime error point of view. But that point already covered to some degree by existing software. Comparing with such point, Spark has a strong point. That is, as I mentioned earlier, this software it behaves as intended. So in order to confirm that point, we have to define the contract. Contract is, let's say, so we define some precondition. Precondition means the condition before a software is executed. And also we define the post condition. Post condition is expected condition after software is executed. So once we decide precondition and post condition in Spark language, then Spark can verify that if the precondition is established, then post condition is also established or not. So through this functionality, we can verify that our software is our software behavior is exactly same as our intention. And of course, it is very rare case that such verification is passed. So we can find out some shortcoming or error. So such a shortcoming might be caused from specification itself or a source code itself. So we try to improve the specification. In this slide, that is included in the contract itself. Or we will improve software code in order to remove some bugs or something like that. So we can do both things in parallel. And then we apply the Spark tool verification again. And if verification is passed, then both specification itself and implemented source code is free from error. That is a very strong point to apply Spark. And if the verification is passed, then we can reuse the existing software contract for next software development also. So we can improve or speed up the software development using this method. This is a very strong point to use Spark. This is one of the major reasons why we decided to apply Spark. Then this is one of the examples in the area that JTEKT have already applied Spark. So honestly speaking, JTEKT has just started to use Spark in these years. So we don't have much experience to use Spark. So we start to apply Spark from very simple code like this. So in this code, let's say, so just to write the flag according to the condition of the software. In this software, non-volatile memory writing functionality status is identified as output. So this is not so complicated software. So some people said that this kind of software, for this kind of software, maybe unit test can be sufficient. Yes, it is, yes, but as I mentioned, this is just a starting point to introduce Spark. In order to use Spark, we should understand how a Spark language is to be described and also how to make the contract. So based on this kind of experience, we try to enhance the area to use Spark. So this is the future steps for for coming years of JTEKT software development process. So for JTEKT, using Spark is very new. So, but we want to apply this methodology to software development, not only very limited scope, but also to apply more wider view. So for that purpose, we should have to make some kind of a standard or guidance document in order to explain how Spark is used, especially how to create the contracts or something like that. These kind of introductory material is quite useful in order to use the Spark internally in the use for our software development teams. That is the first step. And also, so current embedded software is becoming complex and complex. So, of course, even if Spark can help for software unit level verification activities, because the software unit testing need much amount of effort for JTEKT software development. So if we apply the Spark, we can reduce the development effort for such area. But if Spark can also applicable to higher level, for example, software integration phase, then it is also helpful. But currently, we don't have any experience to apply Spark method for such software architecture level verification. So theoretically speaking, Spark can deal with such area of verification, but as I mentioned, so JTEKT doesn't have any experience to enhance the applicability of Spark, so we will investigate the possibility of Spark for this area. And last point is quite important for safety point of view, and actually, so this point is exactly our real expectation to apply Spark. But so also there is some uncertainty for the Spark. This is the verification of functionality itself. So as I mentioned, so Spark can verify that our software behavior is exactly the same as our intention, but that is not certainly, or there are several uncertainty because so the formal verification is based on some kind of a mathematical reason or mathematical theory. And but if we consider about typical embedded system, it is more, how to say, so experiment based. So for example, if we consider about the feedback control system, we should rely on the input information and also feedback information. So it is a little bit difficult to establish some kind of theoretical model in which is correct output, because that is depend on the situation of input and also the feedback information. So whether Spark can deal with such area also or not, that is a very challenging point. So JTEKT is considering to research the applicability of such area in near future. Then if we can establish some way to verify such little bit complicated software verification, then we can apply this method instead of existing software safety mechanisms also. Then we can simplify the software itself, but we can replace existing software safety mechanism to Spark verification, because theoretically speaking, so software implementing software safety mechanism into software is same as Spark verification outside of the software implementation. This is very strong point for the formal verification itself. But this is my dream, so I'm not sure this can be realized or not. This is the future challenge. But I hope that we can address this issue by Spark with support from Ada Core, hopefully. So that's all for my presentation. Thank you for your attention.